Well, hello. We are going to finish math lesson 74 if it kills us, but it's not because it's easy and we know how to do it. So we're going to go through this. We left off on number 9, so we finished number 9, and so we're going to do 10 through 12 together. Then you're going to do the computation all by yourself. If you need to use your multiplication charts, you can, but you know how to add, subtract, multiply, and divide, okay? That's what you're going to be doing on 13 through 27. So I'm going to work with 10, 11, 12, 29, and 30. You're going to do 13 through 27 by yourselves. Then once you've finished, you'll have your parents take a picture of all 1 through 30 and send it to me. If you'd ask them to put on the, what do you call it, reference line or subject line, your child's name, so Dev's lesson 74 math, and just send that on to me. If I could get that by midnight Thursday, today, maybe, I'd be happy with that. Thank you. All right, so number 10, let's move on. What is the perimeter of the rectangle shown to the right? Well, they give us 6 by 4. Well, we know 6 by 4. All right, perimeter though, who can remember? Let's see, if I have a perimeter, 6 by 4. So if this is 6 inches and this is 4 inches, I'm looking for the perimeter. It is the distance around, right, a subject or object. Object. So if this side is 6, what are we going to assume this is? 6. And what are we going to assume if this is 4 inches? Yes, that would be 4 inches. Now the perimeter is, we're just adding it all together. So 6 plus 4 is 10, and 6 plus 4 is 10. So what would my perimeter equal? It would equal 20 inches. Yes? Yay, hopefully your handwriting's neater than mine. All right. Then it says, how many 1-inch squares could be or would be needed to cover this rectangle? So how many little 1 square inches? So they're asking for something, but they're not giving you the exact terminology that we've used in the past. All right, so I want you to think about it. The perimeter is the subject, or the distance around an object. The area is inside of the object. So if I have 1-inch squares all the way in here, I'm looking for the area inside of here. Well, we remember that area's equation is length times width. So area is 6 times 4. So area is 24 inches, what? Squared, exactly. Got it? Excellent. Okay, number 11. How many millimeters are equal to 10 centimeters? And they want you to use the chart, okay? So they give us a chart that says for every 1 centimeter, it's equal to 10 millimeters. 2 centimeters, 20. 3 centimeters, 30. 10 centimeters, right? 10 times 10, exactly. So your answer would be 100 millimeters. Good job. All right, now, this one's crazy. Which transformation would these positions be in? And they've given us this crazy little shape of 2 triangles, okay? Now, what I think we failed, or I failed to discuss, and I don't know that it's really addressing it, but one object can do more than one thing. It can slide, it can flip, or it can rotate from upwards. It can do all of those at one time. You just have to be able to figure that one out. So let's look, let me see if I can't draw this. So it starts with a straight line down the middle. It looks like it's a straight line across. And then it's here and here. So we have S, R, T, P, Q. All right, so this is number 12. I'd like for you to try to draw this on your paper. If you'll notice, there's a one straight line this way and a straight line this way, and then you'll go ahead and close them up to make them triangles. So the question is asking, triangle STR, this triangle here, is what transformation or position as PQR? All right, so if I have STR and then I have RQP, you might think that you flip it or that it's the reflection, but I could rotate it. Let's see here. Got that. Now, this is not a right angle. Well, I guess you could do like this. So here we go. I have, can you see this? Let's see. All right, so here is triangle SRT. And then they want to know, could I rotate it? Yeah, I could, because right angle, right angle. So if I started like so, SRT, and then I rotate, which means I'm just kind of moving around, and then I have that right angle there, I have RQP. All right. So on number 12, you would say that it is rotated or rotation, either one. Okay. So now I have 13 through 27. You're going to do all on your own. It is strictly computation, and I want you to do your best, and then we'll check both 73 and 74 probably on Friday, and we'll see how well you did on the written practice to see if you got the right answers, all right? So let's jump down to number 28. If you want to pause it and do 13 through 27 right now, or you can just start a new sheet of paper and do 28, 29, and 30 together. That's up to you, all right? 28, find the next number in this counting sequence. Well, they gave us 90, 180, 270. 90. Oh, come on. My purple isn't working. 90. 180. And 270. And they want to know what is the new, can you see that? Yeah. They're wanting us to know what would be the next number in this counting sequence. Well, let's figure out the pattern here. How am I going from 90 to 180? There's Biscuit again. All right, 90 to 180. Well, let's take the zeros out. How would I have gone from 9 to 18? 9 times 2? Keep that in your brain. All right, how would I have gone from 180 to 270? Well, if this is 9 times 1, or 90 times 1, then this is 9 times 2, or 90 times 2, then this is 3 times 9, 27, or 3 times 90. So what would the next number? Yes, 9 times 4 is 36. 90 times 4, 360. Ding, 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 ding. Good job. 360. And I'm sad my purple marker's not working anymore. In the trash with you. All right, there we go. Sierra's arm is 20 inches long. So like from here to my fingertips. Of course, I think mine's probably longer than 20. I think that's a good thing. After all this is over, I want you to measure your arm and see if it's 20 inches or not. Anyway, so my arm, or Sierra's arm, is 20 inches. Okay, what am I supposed to do with that information, Miss Taylor? Do I really care how long her arm is? No, except we want to get this math problem right. So, Sierra's arm is 20 inches long. If Sierra swings her arm in a circle, she's probably going to hit her classmate next to her and get in trouble, and they'll be wrestling on the floor, but we're not going to do that. Right, Zane? Right, John Mark? We're not going to do that. We're not going to turn around and slap the next person next to us. 20 inches. The question is, if she turns in a circle very nicely without touching any of her neighbors, what will the diameter of the circle be? Who remembers what diameter is? Remember the diamond ring? Does the girl want the diameter of the diamond, or does she want the radius of the diamond? So the diameter is the whole thing, or it's the radius, which is half. Girls always want the whole diamond. It just is. All right, so I'm gonna take 20 inches and I'm gonna go around and around in a circle. What do you think that diameter would be? I want you to think. Well, 20 inches is half. That would be the diameter. So, I mean, that would be the radius. So what would the diameter be? You remember? Y'all are like, oh, Miss Taylor, you're making my brain hurt. Okay, let me see if I can draw Sierra here. So if she's the little stick person, we'll put her in a skirt. All right, and I know from this point, this is a funny drawing when you get to see it, and I know that this is 20 inches. If she went in a circle, she didn't fall, she didn't slap her neighbor and get in trouble. Now look at it. You remember, the radius is half of the distance from the center of a circle to any point on the end of a circle. So if this is 20 inches, what is the diameter? The distance completely across the circle that goes through the center point of the circle. 20 plus 20 is 40 inches. So the diameter of Sierra's circle would be 40 inches. Good job. Cha-ching, toot, two. Here, I'm throwing candy at you. Duh. All right, so here we go, multiple choice. Which of these numbers is a prime number? Okay, who remembers what prime means? Juanita, what does it mean? Andy, what does it mean? Brock, answer, what does it mean? Prime number is a number that's divisible only by 1 and itself. Okay, so is 9 divisible by 1 and 9? What about 3 times 3? It's not. Oh.
No!
What about 4? It's divisible by 1 and 4, but it's also divisible by 2, right? 2 times 2?
No!
All right, what about the number 2? They're trying to trick us here. 2 is divisible by 1 and by itself, but nothing else. What about the number 1?
For the last time, no.
That's a trick question because 1 is never a prime number. So your answer has to be B, 2. 2 is the prime number in this multiple choice problem. Good. Now you have finished lesson 74, and you'll get it all together all nice and neat, and you will give it to your mom and say, hey Mom, I need you to take pictures of this, or hey Dad, I need you to take pictures of this, and email it to Mrs. Taylor so she can see that I finished it all. Good job. Good job.